As we know, presently we are studying evidence, correct or not? So evidence for what? Particles in matter. Yes or no? So now as we know, particles in matter always will be extremely slow, extremely small, and as well as they will be keep on moving. So that motion, a random motion of the particles only we used to call it with some name. What is that name? Yesterday also I told you. What is that name called as? Random motion of particles. That is what we used to call it as some name. What is that name? It will start with some B. Everyone. Hari, Danishkar. Brownian motion. Brownian motion. So now, if we take the first experiment which have been done, evidence for particles in matter, that is what? Dissolving a solid in a liquid. So we dissolved potassium permanganate in liquid, that is what? Water, and we have been seeing how the potassium permanganate color is spreading when the time is keep on increases. Is it yes or no, guys? Yes, please respond. So now you can take here, in our today's class, we are going to study the next one, that is what we used to call it as the second experiment to show that this evidence for this particles of matter. You can take mixing of two gases. We are going to take today what? Mixing of two different gases we are going to take. Now, if we take here, for that I am taking mixing of two different gases. I am selecting two gases. One is colorless gas and another one is a gas which is having color. So the second experiment is, what is the second experiment? Mixing of two gases. Is it okay, guys? Now, if we take one of the gas, as we all know that air is a mixture of gases. So is it a color or colorless gas, guys? Is it a color or colorless gas? It is the colorless gas. Is it yes or no? So as we know, it is a mixture but does not have color. Is it okay, everybody? Now if we okay, so now we cannot see, even if we take one empty jar, inside nothing is there. So it is filled with what, Tanishka? If it is a normal one, you can see. If you take one glass I kept outside, it is nothing is inside, no water, nothing. But still it is occupied by whom? Gokul? It is occupied by air, because air is the transparent one which we cannot see. So now that is why I am taking one jar, I am taking the air which is filled with air, so which is not seen by, which cannot be seen because it is the colorless one. So now I am taking another one, that another kind of container which I am taking a gas called as bromine. What is another kind of one called as, guys? Bromine. Understand? So now this bromine gas basically which is present in red brown liquid. Actually it's a liquid, actually the one and only non-metal liquid. So basically we can say bromine. Okay, so bromine liquid which is present in red brown liquid. So what is this one, guys? It is the red brown liquid. Understand? So we are taking, sir, then you kept a heading mixing of two gases, but you are saying liquid. So that is what I am saying. So it will easily form vapors. What is happening, Hari? It will easily form vapors. That is, I am taking this liquid. Is it okay, everyone? So why I am taking this red brown liquid? Because to show that the mixing of gases will take place. Yes or no? Please respond. So it will easily form vapors. That is the reason I have been taken this bromine liquid. What is the color of the bromine liquid, guys? Red brown liquid. Understand? That is what. Now, if we'll keep on mixing these two cylinders, if we'll combine these two cylinders, one is containing air and another one containing what? Bromine gas, understand, bromine liquid, then you can see bromine vapors is red brown in color, and also if you notice it, they are heavier than air. What is that another thing? They are heavier than air. So that heavier than air, so that if you notice it, they will be easily mixed each other, and you can notice how the full color will change in both the cylinders. I will show the real experiment photo also, and you can feel it also. Now, if you notice it, red brown gas mixture, then if you pass these two cylinders, just I will show you. You can see red bromine and as well as air mixture. So how it will be spreading, and later I will explain you clearly. Now, if you take the air and as well as what another one, guys? red brown liquid. Okay, air and bromine mix. So practically, usually we have to do the experiment also. It is so bromine mixture. So now if you notice it here, this is the experiment which we people will do, the bromine diffusion experiment. Okay, now you can see, guys, what is the upper cylinder here? What is the upper cylinder? You can notice it. It's a transparent one. What is the cylinder? It is filled with what, guys? It is filled with the air. Understanding? So now if you'll notice it, and if you'll combine this two cylinder with a down, one more gas is there. What is this gas? This is what we can say red brown liquid. What is that red brown liquid? Red brown liquid is only called as bromine. Now, if you combine these two cylinders, then you can see, as we know, this red brown liquid bromine is heavy than water, air, so that air will start mixing, air will start coming down and mixing with this bromine vapors. Okay, so now you can see slowly the bromine is also moving upward. So have you noticed it? Full cylinder, completely both the cylinders is turning into the brown color, red brown color. Have you understand or not? So after some time, what will happen? If you leave it, then both the cylinders will turn into red brown. Is it yes or no, guys?
Yes, sir.
In the sense of what? Particles are made up of, evidence for particles, matter is made up of particles. So we can say here also, so it is mixing of two particles, so that we can say it is also matter is made up of, or every substance is made up of particles. Is it yes or no, guys? Yes, please respond. That is what happens. So if you take here, if you keep the upside down, this air container and as well as this bromine vapors which will form. So you can see the spreading of bromine vapors into air can be easily will be observed. So we can see the moving particles of bromine vapors and air collide with each other, and they will be bounce about in all the directions. Due to that, they will get uniform distribution. So that is why complete cylinders, both the cylinders, we can see in which color, Harish? We can see in the red brown color. Time, so that indicating what? Because the fumes which is formed by bromine, it is easily can form the vapors, so that it can easily spread in the air. So the air and the bromine particles both will collide each other. They will collide and they'll mix each other. You can see before it is empty cylinder indicating filled with what? Ready? It is filled with what? Harish? That is. It is filled with air. It is a colorless. Now you can see bromine vapors. It is red brown color. So before mixing. Now once you will mix them, after some time you can see bromine easily can form vapors and is mixed with air particles, and air particles collide. Understanding? Collide with the bromine. So that what will happen? This collision will leads to uniform mixing. What will happen, guys? It will allow to uniform mixing. After some time, you can see completely red brown color. Have you seen everyone? Please respond. Arun Kailash. Yes, please. Now, this is what we can say. Another example of what? What is the phenomena called as this? This mixing of particles from high concentration to low concentration. What is this phenomena wish to say?
Sir.
Yes, that phenomena only wish to call as. What is the phenomena, please? The mixing of particles from high concentration to low concentration. That is what we used to call as what, guys? Diffusion. Understand? But you can see, even though bromine gas is in bottom, understanding, air is in up, still the bromine is moving up and it is mixing with the air particles. So it is against to gravity. Yes or no? Motion chapter we are studying, even a ball is thrown upward, it will be pulling downwards towards the earth. Is it yes or no, guys? That is what we used to call as what? Gravity. Understanding? So even though bromine gas is at down, air is up, but still the bromine gas is moving upward. How it is possible, guys? Because they are having enough energy. Do you understand it? So they are having enough energy to move forward. So that is what that energy only we used to call as physics will study. That is one type of energy we used to call as kinetic energy. What is that energy, guys? Kinetic energy. So even though you, if you notice it, bromine is heavier than air, even then it will goes up against to gravity and will mix with air in the upper jar because its particles are moving with a very high speed because they are having sufficient amount of kinetic energy. Do you understand, guys? The bromine particles will travel with what? Very high speed. Even though they are present at the bottom, they will move against to gravity because of why? Arun Kailash, Gokul, because of they're having high kinetic energy. That is the reason behind why bromine only moving up and mixing. Is it okay, Harish? Everyone?
Yes, sir.
Okay, so that is why you can see, if you notice it, air present in the upper jar is also diffuses downwards into the bromine, but you can see air is a colorless, so we cannot notice it. Have you understand? So air is also will come down and it will mix with the bromine gas, but we cannot see the movement of air. Why, guys? Why? Because air is
They
a
are
what?
colorless.
Because of air is colorless. So that is the reason we cannot see the movement of air particles. Only we can see the movement of bromine particles because bromine is having a color. That is what we can say, red brown. So once they will collide with air particles, bromine particles and air particles will collide each other, and finally they will be distributed uniformly. That is what uniform mixing we can say. So completely two jars we can see in red brown color. So this is what the second experiment to show that diffusion. So from this process of diffusion gives us always two conclusions. One is what, guys? Anybody can tell me? Again the same thing. For what is the first conclusion we can make? So matter is made up of what? What is the first conclusion? The matter is made up of tiny particles. Understand? That is what the first conclusion. So please all of you note it down. So we can say the first conclusion, matter is made up of tiny particles. The next second one, what is the second one? That is what? Motion. All the particles inside the body. What is that? The particles of matter are constantly moving. That is the second one. The particles of matter are constantly moving. Matter are constantly moving. Is it okay, guys? Everyone? Yes, that is one. So these are the two experiments we can make it. That is what we can say evidence for particles in matter. One is dissolving solid in a liquid, and second one is what? Mixing of two gases. Is it yes or no, guys? Now we can take third experiment. That is what we can say. Even yesterday also I said you, that is what Brownian motion you can take. So if you take pollen grains means in the sense of like you can take talcum powder also, the powder particles which is present in our home. So now you can see, let us observe this Brownian motion, the random motion with a highly enlarged picture to show the phenomena of Brownian motion. So you can see the fastest moving water particles. How? If you take water, how this water is moving always, and it is hitting the pollen grains and causing to move in a zigzag manner. That is all will prove it. Now, if you notice it here, movement of pollen grains in water is the third experiment which we'll use to prove the, what is that, guys? Particles are always in moving. Is it okay, Harish? Yes or no? So that is what. So please all of you keep heading. The third experiment is movement of pollen grains in water. Movement of pollen grains. Or else you can take chalk piece powder also, boys. Everyone. Or else a talcum powder in our home. Everything you can take. Okay. So why we are using this experiment? Anybody? Movement of pollen grains in water. Pollen grains. Why this experiment? Anybody can tell me? Pollen grains in water. Why we are doing this experiment? To prove that the particles inside, understanding, is always are in motion. Do you understand, everyone? That is the reason we are doing this experiment. Please at least try to respond. So to show that movement of particles in liquids, always, as we know, the particles are not in a single position. What is the second conclusion we made, guys? What is the second conclusion? The particles of matter are constantly moving. Yes or no? Yes, please respond. Nobody is responding. Correct? So that is what. So if you'll notice it, that is the second conclusion which we made. So the matter is made up of tiny particles, and the second one is the particles of matter are constantly moving. To show that constantly moving particles, we are taking movement of pollen grains in water, or else you can take the talcum powder in water. Is it okay, Harish?
Yes, sir.
Tanishka, Arun Kailash, everybody. Now, how it will be happen means take one bucket of water, or you can take one container of water, normal like this. So this is what water. Is it yes or no? Yes, everyone.
Yes,
Now,
sir.
if you notice it at the top, pollen grains means biology. People always. Pollen grains means if you touch the flower, you used to get some kind of yellow color powder like substance. Have you noticed it? That is what we can say. Six gametes in flowers. Understanding? So six gametes in as well as gametes we used to say in the flowers. It may be a male or female. So yellow color powder will be there in the flowers. That is what we used to say pollen grains. Is it okay? Like this, you can notice it. Yes or no? Yes, please respond.
Yes, sir.
So now take these pollen grains, or you can take talcum powder. That is better. So talcum powder and put on the surface of water. Okay. Now, if you put on surface of water, are you able to see these pollen grains or talcum powder in single place? We'll never see
No,
it in
sir.
single place. You can notice it. It will be continuously moving on the surface of water in random directions. So, how it will move, guys? Is it any motor is present inside this? No motor is present. Yes or no? How it is happening? Because the bottom particles, bottom who will be present? The water. Do you understand it? So the invisible force, that is what water molecules are keep on moving. Water molecules are moving continuously, understanding, in a constant rate. So that is why when the water molecules move, so that the particles which are present in the water, they also will move in random direction. Yes or no, guys? Yes, please respond. Yes, Harish. So that is what we used to call it as Brownian motion. So from that, what we can conclude? So the particles inside the every matter, you can take liquids and as well as gases. We can see how the particles are moving in the random direction. Now, and also the second experiment also I will say. How many of you shown that in early morning when you are sleeping in the room, the sunlight is coming from the pinhole of your window. If you take this is the window, the light is coming from the window. Have you noticed it? Clearly we can see the dust particles floating in the light. Have you noticed it or not?
Yes, sir.
Normal we
In the
cannot see.
morning, sir.
Yeah, morning when we are sleeping on the bed, suppose as light is coming from only small hole. Danishkar, have you feel completely closed, sir? Yes. You might be seen, guys, in our home. Have you feel or not, Arun Kailash? So you can see by that time a clear structure of floating of particles, dust particles, and etc. in air. Understand? So that is what indicating what always in particles. So but normal time we cannot see. By that time the sunlight intensity is different, so it will make us to see the particles. But normal air also same thing. Yes or no, Gokul? Every time air also same thing. The particles are keep on moving, but the light which is coming from the pinhole from early morning, we people can notice that very clearly. So this all the experiment is indicating what? It shows that movement of pollen grains in water or talcum powder or as well as dust particles in air. Everything is indicating what? It is shows that the second conclusion. What is the second conclusion? Particles of matter are constantly moving. So that is what we is to show that we are using this experiment. Now this random motion of the particles is only we is to called as, what is that motion called, guys? Brownian.
Brownian motion.
Okay, so that is what you have to remember. Now I will show you the magnified image of these pollen grains kept in water, so that how it is moving you can see. So have you noticed it, guys? This is what the pollen grain, highly magnified image. Is it okay, Harish? Danishka?
Yes, sir.
Yeah, this is the pollen grain.
Yes,
Understand?
sir.
Talcum powder. You can see it is continuously moving and it is forming a zigzag path. This is what the path formed by understanding this pollen grain. So now you tell me how it is happening because of, see, this blue color one. What is this one? Anybody can tell me what is this? What is that, guys?
The water.
Water. Do you understand it? So this is what we used to call it as water molecules. So when the water molecules are moving randomly, you can see they are moving randomly. So that is why it is causes to exerting force on the pollen grains. So pollen grains also will travel in the random manner. Yes or no, guys? Will you accept it? Everyone?
Yes, sir.
Yes, that is what.
Yes, sir.
This evidence for the existence of movement, understanding of particles in a liquid and as well as gas. First, it was given by Mr. Robert Brown in 1827. Understanding? What's his name? Robert Brown. Understanding? So that is why it is called as which motion? What motion is called as? Robert Brown. So that is why it is called as, what is that motion we used to call as? Brownian motion. Understand? That is what. So please all of you note it down. Brownian motion. So what do you mean by Brownian motion? I will give the definition. This is the path you can see. So this is the pollen grain. It is following the path like this differently. So because invisible moving particles of water continuously hit these pollen grains and it will make it to move. Are you clear, Arun Kailash? Why it is moving? Yes or no? Please respond. That is what you have to remember. So the pollen grains move on the surface of water because continuously it is hit by fast moving particles of water. So that is what it is causes the motion of pollen grains or talcum powder, etc. So it is indicating what? It is indicating Brownian motion. We can say that
Brownian
particles
motion.
inside the matter are in constantly motion, constantly moving. So this motion only we used to call it as Brownian motion. So this Brownian motion we can observe in gases also. Yes or no? Yes, please. Yes. What is the example
Yes,
of
sir.
Brownian motion? Where we can observe the Brownian motion in gases? Anybody? Where we can observe the Brownian motion? That is what I said. Dust particles in sunlight. Understanding? So the beam of sunlight entering a room, you can see. Understanding? A tiny dust particle suspended in air, moving rapidly in a haphazard way. That is what zigzag manner. So that is what example of Brownian motion in where, guys? Brownian motion in air. So that is what even I will show you. You can see. So Brownian motion in air, we can show. Brownian motion. You can see. You might be notice it. You people not seen. When I'm in child, I used to see every time. Can you people are not seen?
Right.
Others, any other? You people are not seen.
Sir, I see, sir.
Yeah, this is what see. The light is coming from the window or small hole. You can see. Can you able to see the clear path of the particles and how they are moving, floating up particles? Yes or no, guys? Yes, please respond.
Yes, sir.
That is what we used to call it as Brownian motion. Understanding? So this is what we can say Brownian motion, and as well as the Brownian motion, how we can prove that the particles are moving inside. Why this floating, the dust particles are floating in the air? Because of continuously air particles, that is what nitrogen, oxygen, and as well as carbon dioxide, they are keep on hitting these dust particles. So that is why dust particles are keep on displacing. Is it okay, everybody? Yes or no? So that is what we can say. Second example of that is what Brownian motion in gases. Okay, guys, please respond. Brownian motion in
Okay, sir.
gas. Yes, Hari. Yeah. Respond. Yeah. What is that? Somebody is asking something. Okay. So now if you want to prove movement of Brownian motion in liquids, you can prove pollen grains are with the talcum powder. Brownian motion in gases means you can take the sunlight which is coming from, which is entering into a room. So we can see how like zigzag manner the particles are keep on moving. So we can say that is an example of Brownian motion in gases. Because of air is a gas, mixture of gases. So these tiny dust particles move here and there because they are constantly hit by whom, guys? Constantly hit by the fast moving particles of air. So air contains what, guys? Air contains what, Danishka? Nitrogen, oxygen, carbon dioxide, and etc. So these particles will hit these dust particles very fastly. So that is why dust particles are keep on moving. Is it okay, guys? Dust is moving, so it is indicating Brownian motion only. Please respond yes or no. Have you understand? Yes.
sir.
That is what we used to say. This is the third experiment to prove that particles are moving constantly. That is what. So please all of you write Brownian motion. So it has been given by whom, guys? Mr. Robert Brown in 1827. Okay. So here also you can remember 1827. Mr. Robert Brown has been proved the experiment to show that random motion of particles inside the liquids. Okay. So that is what you have to remember. Now, if it is permits, you please also draw the Brownian motion diagram also, which I have been shown. So this is the diagram which you have to draw for Brownian motion. Will you able to draw, Arun Kailash?
Yes, sir.
Okay, that is what we have to do it. Gokul, you also Brownian motion diagram you have to draw.
Yes, sir.
Down, write the definition of Brownian motion. What is the Brownian motion? Two examples. Moving up pollen grains in water. Second one is what? Moving up dust particles in sunlight. Understand? We can see when the beam of sunlight is entering into the room. We can say example. Brownian motion can observed in gases also. That is what? When tiny dust particles are suspended in air, which are moving rapidly in a that is what haphazard way we can say. That is what random manner because of fast moving particles of air. That is what. So we can say example, sunlight enters in a room. When a beam of sunlight enters in a room, so we have to explain. They may be asking exam question. What they will ask you? Explain the Brownian motion in gases. Is it okay, guys? So by the time you have to explain what? When the a beam of light is coming to the room. Okay, guys? Beam of light entering into room. So we can say example of Brownian motion in gases. So we have to explain very clearly. Is it okay, everyone? And we have to put a statement because of random motion or fast movement of particles of air like nitrogen, oxygen, carbon dioxide. So the dust particles will be keep on hitting by them so that they will move in a random manner. Is it okay, Hari? That is what we can say, haphazard way. Haphazard way. If you want, you can write haphazard way. That is what random way we can say. Okay, haphazard way we can say. Haphazard random motion. Okay, that is what we can say that. Okay, now please all of you write Brownian motion definition. The zigzag movement of the small particles. The zigzag movement of the small particles. The zigzag movement of the small particles suspended in a liquid or gas. The zigzag motion of the zigzag only random. Understand, Ra? The zigzag motion or movement of the small particles. The zigzag motion or movement of the small particles suspended in a liquid or gas is called suspended in a liquid or gas is called, what was to call, Tanishka? What we used to call Danishka? Arun Kailash? Danishka will never open the mouth. That is what we used to call as? What we can say? Brownian motion. They're very, very silent fellows. I don't know why like this. So please all of you write. This is all about it. So from this also we can make again two conclusions. What is the two conclusion we can make? Everybody can tell me what is the two conclusion? We can say particles are made up of, matter is made up of tiny particles. And second one is what? So first conclusion,
Particles are
made up of tiny particles. Matter made up of tiny particles. And what is the second conclusion? Others also open the mouth. Don't simply say.
Particles are continuously moving.
Particles are constantly moving or continuously moving. You can take particles are constantly moving. For every experiment, we are making the same conclusions. Particles are moving constantly or constantly moving. That is what we can say. So these are the two conclusions which we can made by this experiment. So totally, how many experiments? Danishkar only will answer. Or Gokul. What are the 3 experiments we have been done? First experiment. Anybody? First experiment is what?
Potassium permanganate.
Potassium permanganate. What is the name given for that? What is the name given for that? Dissolving a solid in a liquid. Understanding? That is the first experiment. Second one, mixing of
Mixing 2 gas.
what is the 2 gases? Air,
and bromine.
colorless
R
air,
and red brown liquid.
red-brown liquid. That is what bromine gas. So why we are taking bromine gas? 2 properties. One is it will form vapors very easily, and as well as second one is what? It is heavier than air. Understand? So even though it is heavier than air, it is moving against to gravity. How? Gokul, Arun Kailash, it is moving even though it is heavier than air. It is heavier than air. It is moving upwards. Why, guys? Because they are due to they are having high sufficient kinetic energy. Do you understand, guys? High sufficient kinetic energy. They will overcome the force of gravity or gravitational force. Okay. Next one, movement of pollen grains in water, and as well as the dust particles floating in the sunlight, in air, when we can see a beam of sunlight is entering into a room. So these all are examples of all the experiments. We can prove that 2 conclusions we can make. What are the 2 conclusions? Random conclusions. One is what? Matter is made up of tiny particles, and the second one is what? Particles of matter are constantly moving. So this is what it is. So now we are going to study. This is all about the 3 experiments to prove that. What is that? This experiment? Evidence for particles of a matter. Okay. Now we are going to study characteristics of particles of matter. So please, all of you keep heading. So what is the final characteristics? We have to come to characteristics of particles. So from the experiments we have been made conclusions correct. So now we are going to write what are the characteristics of these particles of matter. Write it. Characteristics of particles of matter. Characteristics of particles of matter. So what is the characteristics? You noticed it one by one. You people tell me. From this 3 experiments, we have been made some characteristics. We can come. What is that? The particles of matter are what? Very, very small. That is the first one. The particles of matter. The particles of matter. The particles of matter are very, very small. Next, second one. Anybody? Particles of matter have what? You can see. Brownian first experiment. What is the first experiment? Potassium permanganate dissolved in water. How it will dissolve in water? Because particles having spaces between them. Yes or no? Particles having spaces between them. That is why potassium permanganate is mixing. Is it yes or no, guys? Yes, Danishkar, Arun Kailash?
Yes,
That is what. So we can say that from that, of course, solid does not have spaces, but other than solids, liquids and gases, they have spaces or not? Yes or no? That is the second one. So we can say particles of matter have spaces between them. Particles of matter having, or we can say, have spaces between them. Spaces between them. Next, third one. Particles are constantly moving. Yes or no? That is the third one. The particles of matter are constantly moving. The particles of matter are constantly moving. That is the third one. Now, last one is, as we know, any 2 particles if we take, they between them some attraction force is there or not? Everyone? Some force of attraction will be there. That is why particles are together. That is what we can say. Particles of matter attract each other. Particles of matter particles of matter attract